let's look into some illustrations on the binomial distribution. Question number 1. If x is a binomially distributed random variable with parameters n is equal to 8 and p is equal to 1 by 4, what is its standard deviation? So, with n is equal to 8, p is equal to 1 by 4, q will be 1 minus p, which is 3 by 4. The variance is npq, which is 8 into 1 by 4 into 3 by 4. So, this becomes 3 by 2. So, the standard deviation is the square root of 3 by 2. So, option A is the correct option. So, this is a very simple startup problem where you are just using fundamental properties of the binomial distribution. The questions which are possible are given the parameters estimating the mean, standard deviation or variance, or given the mean, standard deviation to build a distribution, and so on and so forth, which we will see in the next few questions. Question number 2. A binomially distributed random variable has mean 3 and variance 3 by 2. Then what is the distribution? So, what do you mean by distribution in this case? The probability distribution of a binomial distribution is q plus p to the power of n. So, what we have to do is, from the information given, mean and variance, we will have to estimate what is n, what is q, what is p, and then write the distribution. So, you all know mean is np. So, np is equal to 3. Variance is npq. From these two equations, even though we may feel there are 3 variables and only 2 equations, let us not forget that q is 1 minus p. So, effectively it is only 2 unknowns. So, the easiest way is to divide npq by np is equal to 3 by 2 divided by 3. So, this gives q is equal to half. Once q is half, p is 1 minus q, which is also half. Therefore, the binomial distribution is half plus half to the power of, now n has to be estimated. Now, once you have p and q values, you can go here and find out what is n. n is equal to 3 by p. This is 3 by half, which is equal to 6. So, the distribution is half plus half to the power of 6. And the correct option for this problem is B. A fair die is tossed 7 times. We are not talking about question number 3. A fair die is tossed 7 times. And what is the probability of not getting 5 or 6 even once? So, let us look at this problem. You are repeating a trial 7 times. So, n is equal to 7. Remember, n stands for the number of trials you conduct. And here 6 is getting a 5 or 6 on a die, on a coin, or rather on a die. So, if you look at the sample space, we got a die. When you toss it once, these are the 6 possible outcomes. So, when a die is tossed 7 times, each of these numbers have got equal probability of getting displayed. Now, our focus is on these 2. So, P is probability of getting 5 or 6. This value will be 1 by 6 plus 1 by 6, because 5 has a probability 1 by 6, 6 also has got a probability 1 by 6. So this will be 1 by 3, which makes q is equal to 2 by 3. Now, if you say x is the number of successes, this question says not getting 5 or 6 even once. That means in this problem x is 0. So the question is to estimate probability of 0 successes. Whether we can go for the binomial distribution to estimate the probability is the decision we have to take. Yes, because n is only 7, it has not exceeded 30, and p is 1 by 3, which is not small, it's about 30% possibility. So we can go for the binomial distribution. nc 0, p power 0, q power n minus 0. This is 1 into q power n. Q is 2 by 3 to the power of 7. So this is the symbolic representation of the probability, and a very simple calculation. You can see option C carries the answer. So this is a very simple demonstration of how the binomial probability law or the mass function can be applied. The only thing is the decision making, whether it's to be binomially done or any other distribution. Conditions for binomial are favorable because n is only 7, not exceeding 30, and p is 1 by 3, which is not small. Question number 4. This is a problem related to calculation of modes. Suppose x is a binomially distributed random variable with mean 2 and variance 4 by 3. How many modes exist is a question. Remember, binomial distribution is either unimodal or bimodal, either one mode or two modes, nothing more or nothing less. So let's consider the quantity n plus 1 into p. Now this will decide everything. But before we can do this, we must calculate what is n, what is p. So, given mean is equal to 2, we can say np is equal to 2, and from the variance, npq is equal to 4 by 3. So npq divided by np will give us q is equal to 4 by 3 divided by 2. So q is 2 by 3, which implies p is 1 by 3. And from this quantity, n is equal to 2 by p, which is 2 by 1 by 3, which is 6. So we have p, we have n. So let us calculate n plus 1 into p. N plus 1 into p is 6 plus 1, 7 into p is 1 by 3. 7 by 3, which is 2 plus 1 by 3, and it's not an integer. So if you go back to the principles, whenever n plus 1 into p is not an integer, then the distribution has exactly one mode. So the binomial distribution has exactly one mode. So the correct option for this problem is A.